And again, I'm speaking of the recordings, I'm uploading the videos, so they should be available as soon as Google finishes processing. The first part of today and the first part of yesterday will be available, and when we time allowing, the rest of videos will be added on either today or tomorrow. So the links will be on YouTube, so you'll be able to find them and watch them at your leisure. Again, so later on. So, and also I'll add the links here. There's a link here, but it is not yet ready. So Google is doing processing here. Actually, it is recording. Yeah, it is actually ready. So it is actually ready. So yeah, you can watch the first part of today. You can watch it already. So that's good to know. And this also will be available, publish, but probably available in a few, about 10 or 15 minutes. The first part here. All right, and we'll add that. Let's see. I'll add the link to our GitHub repository here. It should be available in a moment. Like here. We'll do it here. Video. Day 1, part 1. Okay, so that should be ready in a few minutes. Well, depends how busy Google servers are. Okay, so our second part. So we saw how NLTK we can use for exploration, for some visualizations actually, and we'll go deeper into visualization data. Maybe we won't go anything very deep as far as analysis, but so we'll open up day 2, part 2, visualizing data with Matplotlib.
One thing before we start on visualizing, maybe you can show that there are more Nltk notebooks that people can explore on their own.
Excellent, right. So yes, there are more Nltk notebooks. We use them also in previous workshops. Things like using statistics, more on collocations and bigrams. Bigrams being collection of 2 words, 2 tokens. And so there are 1, 2, 3, at least 4 more Nltk notebooks in our repository. So how would you use them? Well, you can click on the link, right? You could use it locally on your Anaconda, right? If you want to use Colab, you need to find the link to it. So I'll show you a little trick. So if you open it up here, right? Remember again that GitHub is a static viewer of these notebooks. You can see what's inside them, but you can't run the code because GitHub is not in the business of running notebooks. Maybe someday they will. I will not. Microsoft might decide to offer this functionality, but for now you need to use Colab or something else, right? So, well, actually, I have a little extension, Chrome extension, which does it for me. But basically, you can figure out the address. Right, if you know the notebook, there's an address here, for example, for statistics, right? So basically, it's Colab Research Google.com, then it's GitHub, then it's the repository owner, that's me in this case, it's a repository, and then there's a blob, main, and then the folder where the notebooks are, and the folder name. So you can figure this out for any notebook publicly available on GitHub. You can open it up in Colab. Again, there's a little extension, but you can do it by hand, basically, with little know-how. Maybe there's a link. Uldis can find a link on. There's also links. There are also links to how to do this. But again, it's not really that hard, right? You can figure it out yourselves, I believe. Right, so any notebook, if publicly accessible, you will be able to open it as such and run your own code. Download the code later on, right? And basically run it as your own. So it's quite nice, works quite nicely. So any other questions before we move on to, this is Python 1, next.
Are we on visualizing data with Matplotlib?
Yes, second part, yes. Today, day 2, part 2. So day 2, part 2, right? Let's check our content.
Has something changed in that output too, since yesterday?
Yes, some things have changed. Yes, good point. Things have changed. Yes, indeed.
So please update.
So yes. So question again. Those who are using Git, you do Git pull, right? If you are basically want to, you can download. Can you download a single notebook from a repository of somebody's notebook? You want to download to your computer? You can, but you need to have this link, raw link, basically. copy link address, and you can, or save link, I think save link as raw. I think that would, yeah, that would download, yes. Yeah, that would download it locally somewhere. That's a possibility as well. However, you can of course always download the whole shebang, so to say, right? Download the whole repository with a zip file, right? So of course, if it's a huge repository, it will get all these zips. Of course, it's kind of not very efficient, right? But that's why you have git pull. But it is a possibility to get everything, right? Again, so for those who are using Colab, of course, you don't have to do anything. You just open up, and automatically you'll have the latest version here, right? So I'll open it up here. So this is visualizing word frequencies for custom data. Right, again, I adapted this notebook from Nathan Skelber's notebook, but added some extra stuff also from my own data sets and my own visualizations. So the part, what are we going to do? We're going to do more work with word frequencies, because that's pretty much the basics everywhere. And again, we'll need to load our data. Again, we'll doing things we already did yesterday and today. We'll go over. Again, we'll be the process data, do some stop word filtering, and of course we'll be using counter again to have these get the most common words, and then we'll visualize the results. Right. So let's get started. We'll use a little bit of NLTK. Time allowing, we might use NLTK more to maybe have more cleaner data, and we'll use counter. Of course, we'll use Matplotlib for visualizations. We'll use WordCloud library and Plotly. Out of these libraries, I believe all of them are included in Colab, right? And also they're all included in Anaconda by default, right? Those who are using Visual Studio, you might need to install some of them. So let's see. So we need to first, of course, load the data, right? Again, I'm going to run it. This is my notebook, right? So I'll agree that I agree to use it. And of course, I have my machine now. Again, it's still 12 gigabytes of RAM, still 100 gigabytes of space. Okay, so again, I'll be using this address. So if you remember, if you want to use a bigger corpus from or you would need to change this address to, you need a compression zip, right? All this, if you want to have a big corpus.
Yes.
If we have time, again, at the end, we can see working with a bigger corpus, because you will be asked to work with your own corpus at the end of this this session. So we have URL. So this should work for everybody. Pandas, again, separator T, tab, and head. We're going to check if everything worked. So this will be, of course, again, let's double check if it's should be shape, should be still shape should be 4,000, almost 5,000 rows or records, right? So now we talked a little bit about stop words. Did we talk about in NLTK a little bit?
Not really.
Not really. Yes. So often when you're doing some sort of analysis, you don't really want some commonly used words. You want to exclude them, basically. And for different languages, there are different lists. So achieved by basically hand-picked words list. So the words which are usually not don't add any meaning for analytical purposes. They might be useful. Sometimes you don't want these all stop words gone. So it depends. You need to check what are you excluding. So let's take a look. How do we download stop words? So NLTK actually has a list of stop words available. Unfortunately, Latvian is not among them. Again, right? There's, I think, so you can see it here. You can check the languages, I believe. He has a list, right? So Latvian is not, I think Estonian and Ukrainian is also not among them. So there are many ways you can build your own, right? It's just basically a text file, one word per row, right? Basically a simple text file, right? There is a repository, github.com stopwords ISO, right? So apparently a standard, right? I don't think it's that completely standard. Stopwords ISO, right? So, and it's for different languages, many of them, I think, here, right? So there's Latvian one here as well. There's Latvian one, and again, it's a good starting point again for your own language. So here is the link, right? For Latvian, you can try Estonian or Ukrainian. Also, it should work, but of course, you will need to change this address as well, right? You need to check if this repository exists, right? So for your other languages. So what we'll do is we'll start with an empty list. Of course, we don't have to actually have an empty list. So what we'll do is we'll ask for response, right? We could make a request using request library. If response is normal, 200 means everything went okay. 200 means our request was successful, right? If we got 404, we did something wrong. Right? We can add else. Let's add an else statement here. Else, something went wrong. Oops, some error code, and we can add our response status code. This is from a web browser, as you've all seen 404 errors, right? Again, tomorrow when you do work with web scraping, I'm sure you'll see more of those. So this means if you made a mistake in making your URL is not correct, or or maybe something's not offered publicly, possibly as well, right? So you can check this as debugging, right? This extra else. Okay, let's see how many stop words we get. Again, we got 161. If this is 0, so length is 0, so len stop words is 0 here, right? So we can see if we get anything is 0 here, right? So let's take a look. So what happens if this will work? 161. So everything worked. Let's take a look what we have here. So stop words in Latvian. Let's take first 5, and we have, yes, it looks like it's alphabetically sorted, right? So these are again the words deemed by this compiler, this human curator, that these are not important. Okay, once again, you need to, depending on your subject of your research, you need to see if, okay, maybe these words, some of them have meaning in your context. So, and also it doesn't include, of course, not everything is included here. So sometimes it's like, again, it's a little bit of a judgment call. So what else? So yes, again, if you look at the address, right, I can show you what it looks like. Again, you can always check the address directly, right, because that's what we are doing here. Again, this is going into web scraping, but that we are basically, when we make a request, this is basically same as going to this address, right? Here it is. That's what we downloaded. It's a list of words, right? So let's see. I'm gonna guess UA. Let's try. Is it present? Let's try this. I don't know. I'm just guessing. This is just a guess. It might not exist. Nope, not 404, not found. That's what you'll get if UA. How about ET? Right? Let's try this. But it's of course you have to go and see if it exists. Oh, it exists. Estonian exists. It's very small. It's tiny. I think it's too little, right? So you probably have a better one. Those Estonian ones, you probably have your own stop words list. But so what is OMA? Oh. Yeah. Okay. Got you. Okay. I thought maybe they excluded grandma. Okay. Right. So it works actually. For Ukrainian, you need to check. And for Finnish, I think there are more resources or for Finnish ones. Again. So for English, of course, you can find many different stop words. In fact, you can use the code below. Will work for English words. Will be automatic. So this open stop word CSV. We can want to save it, right? We want to save this again. Remember, this is not required, right? I'm going to use CSV. Well, it is technically a CSV, except there's no commas, right? Because it's one word per line. You can use anything else. You can use the mother standard. You can use just a text file, right? It also would work, right? It's open. We save it, and we have it here, right? Let's check it out. So, since Google Colab has a built-in CSV viewer, right? In this case, it's a single column, right? It's tiny, but we can check it out, right? Might be something you can do also filtering. It has a built-in CSV. Again, it's for your own convenience. Again, remember that this is gonna, unless you save it onto your Google Drive, mounted drive, this will go away when you finish your notebook and you go away from your notebook. Okay, so we have our data, we have our stop words, right, our preparation. And here is a little example how we can load stop words from a CSV file again. And if we can check, so we have a blank, we start with a blank stop words list. Technically, this row, this code is not needed because we already have. I mean, we don't have to run this cell. That will show it to you again. So I'll load it from an existing list of words, right? So again, it could have been could have been text file, because it is really a text file, right? So we have a blank file, we have a list, and here is an interesting, this might be useful for you if you want to have some extra error checking. This code checks if this stopwords CSV file exists here, right? In your directory or somewhere else. Then what you do? Well, we could have used pandas, but we're going to use a built-in CSV library. In this example, they use that. And you open this up, the reader, and you take the first column from this reader, because of course you read a row of CSV data again, and you take the first column, and then you have your custom stopwords list. So basically, we save the CSV and then we load it back. However, if it didn't have this file, it would load the Nltk stopwords list, the English one, right? Well, I could show you what it looks like. I think we'll take a look at Nltk stopwords.
Well, let's do that.
Let's do that. We can do it separately, right? So because it exists, right? If I say bad file, right? Bad file, right? So it doesn't exist. It's not here, right? So what will happen? It's going to fail. This is going to be false, right? This is going to be a false statement. So this will not work, but it will work here. Out of these two rows, it will load this part here, right? Let's take a look. So let's see how it works. On stopwords Nltk. We needed to, of course, download Nltk stopwords, right? So that's also might have been done here. Could we do this here? I wonder. Nltk, import Nltk. Yeah, so we had to do it before probably. I wonder if you can do it here, right? Import Nltk. Let's try Nltk like this. Okay, this might work. Let's try it. Yeah, 179, it worked, right? So what we did is basically selective import. We say, okay, we only need Nltk if you don't have any stopwords, right? Again, just using it for that purpose. So let's take a look what the English ones look like. But they're not very useful for us in, not 5 stopwords. Let's see the first English ones. I, me, my, myself, Irene, right? So me, myself, we, right? So okay, so that's the English one. But okay, but we'll fix the file name. We'll go back to, we'll do a correct one, right? So I'll do a correct one. So now I should have a correct list of words. It will run here. So now I have 161, and let's run it again. And I will have okay, that's Latvian. Okay, so we're back to this row. Okay, so again, so this is just a code. If you have a CSV format file, basically as a list of words as a CSV file with a single column, which is basically a text file. Okay, so we want to gather, or unigrams, of course, right? We want to clean up. We'll do a little bit of cleanup. I think we did more cleanup in the first session today, but just a little bit. So we have, let's double check first what we have. Okay, we have text. Again, we have 4 columns, right? And text column is what we want, right? So again, we'll convert the text column to documents. It's a list of text. It's a list of strings. So this is list of 499 strings, right? And we can join them together, right? We use again new line to join, and this will be a huge text again with of about 1,400,000 something symbols, right? Unicode symbols, and then of course first usually what we want to do is again text lower. We're going to lower the lowercase, or we could do uppercase or capitalize, but to start the normalization process. Again, sometimes of course you need the extra. You want to make a distinction sometimes between these. Sometimes if there's confusion, maybe there's a capitalized word which is separate from the normal lowercase word. But here we'll use lowercase because our emphasis here is on visualization, maybe less on analysis. So text lower. Let's take a look actually. I didn't do here text. How many do we have? So did we? How many? Well, it should be still the same, right? We just did lower, right? So it shouldn't. The number should be same, right? Yeah, of course, because we didn't do any replacement, any cutting, anything like that. So it's still the same number. So see what happens. Split. Okay, so here major alternative would be the thing we did we did in the first session. Nltk word tokenize would be Nltk's word tokenize, right? This is our manual tokenizer. Again, if we have time, we'll see what happens when we do some cleanup. So of course, again, garbage in, garbage out, right? If we have a really bad data set, we might need to do more cleanup, right? So we should have 190 tokens, right? But again, so this will mean here, so we split again, because we split or foo on foo will be different, right? Tokens, right? So that's the thing. We didn't tokenize commas and pom. They will be part of the words, right? So it's not, again, this just gives you a rough idea. Okay, but we have our tokens, right? And we can do something here. This is it might be useful for you. We have a list of tokens, right? So tokens is a list, right? Type tokens is a list. It's just a list of strings, right? Right? We can check that what's inside type tokens. First one, right? Or pretty much all of them, right? Are string, right? So each token is a string, right? This is a list, right? We have a list of tokens, right? So now what we can do some more extra cleanup. We want to get rid of. We're going to use isAlphanumeric. This is a string method, and if you check, this should cut down quite a bit, right? So we can check. Do we have any? Let's check for dot. Let's take a look. Is there a question mark in tokens? I don't know if it's there. False. Actually, there's no question mark in here. There's no question mark in tokens. That's interesting.
Well, it's not separate question mark because.
Yes, that's a good point. Yes,
it's at the end of other tokens.
Right. So, interestingly enough, let's see what else is there. How about dot? True. So there are some dots, some standalone dots. So I think we'll get rid of those. Apparently they are standing alone, not connected to any word, right? So again, this is a little bit of extra cleanup just in case. So what happens here? So this is basically a loop. This is so-called list comprehension. A really nifty thing in Python, right? So we loop through tokens and filter out items with using our if statement, right? So basically, we go through tokens, and we keep all. I mean, this token is just some name I made up to make a meaningful name, right? And we keep all tokens if this token is alphanumeric, right?
But here we have to be careful because due to the way how this is split into tokens,
yes.
The tokenization, for example, if you would have a word Riga, comma,
yes.
if comma would be at the end of Riga, it will not be alphanumeric.
Okay, so that's a good point actually. Let's double check this method. This might not be here best idea, right? So Python, let's read the documentation on this again, how it works. If all the characters are alphanumeric, so this means it will cut off letters. So this would work, but you would lose these extra. So it will lose Riga dot. It will lose all these extra weird names. So this may be not the best idea actually, right? So you can do it, right? If you want to check, right? But might not be best idea in this particular case. So let's see what happens if we keep it, right? Or maybe even better, let's use Nltk word tokenize. That would be even the best. So let's do that. We have time. So let's do that here. Right, let's see what happens if we use. Do we have an LTK? Right, so will be tokens. Will be an LTK word tokenized, right?
Mm-hmm.
Yeah.
If you imported it.
I imported it. Yeah, it's just it needs a word. Yeah, there we go. And they need download punctuation, right?
Yes, but it will prompt you for
it will prompt me. Okay, it will prompt me and I'll do text lower, right? Yeah. Okay, and I want to see how many do I have. So it'll be interesting to compare, right? So let's see how it compares. Okay, yeah, we need to download punctuation. We need to download it. I usually do it in uppercase, right? So again, okay. So I expect we'll have more. Why? Because we're going to split off dots and commas and everything. Yes, we have about 30,000 more. Okay, so now is alphanumeric should be much more relevant, right? So let's take a look now. So now this should work. So we have 230,000 tokens, and we are going to clean them. Yes, we're going to keep only those tokens which are, you know, not syntactic code tokens. Again, if you're doing, of course, analyzing syntactic tokens, right, then you would do it reverse. If not, you could do that. If not, right, and you could keep all the non-alphanumeric tokens, right? That would be a possibility. But these are, we want words. We want words, right? Instead of tokens, we want words. So let's take a look. Okay, 187,000. That looks pretty good. Actually, it's pretty close to our original split, by the way. So it looks like it worked correctly, right? We got rid of all the punctuation, and we actually have words, right? This is just a list of words, right? So let's take a look at some of these words, right? Again, this is probably from the first article, right? So let's take a look. Vinya, yeah, okay. Something about bad smoking. Something about dangers of smoking. Okay, first article. Okay, so now we have words, and remember we want to get rid of stop words. So how would we get rid of stop words? We'll use Python for this. Again, Nltk also has some methods for dealing with stop words, but we'll use just regular Python. Let's check what our stop words are. Yeah, it's still in Latvian, right? It's a list of words. So here's this is a useful recipe to get rid of extra items. Again, in this case, these are stop words. In Python, very Pythonic way of filtering. So basically, you have a big list of something. In this case, these are words, and you have a list of bad words. So in this recipe, you can filter out all the stuff you don't want. So basically, again, so you go through all the words in your list, and you keep the word if it's not in the stop words list. Because why? Because this, remember, not in, right? In checks, we basically go through all the 90,000 words, and we check, okay, is this word in our stop words list, right? So if it's not, we keep it. If it is in, we discard it. We don't use it. So this should be nicely about 100-something thousand, probably a little bit different because let's take a look. Yeah, 150,000 again. So quite a bit more. So we keep only those words that are not in our stop word list, right? Okay, I can do it again, of course, right? Words clean, right? And again, I will just use a simple counter for now, right? Basically unigram counts. Basically, these are unigrams and words, you know, unigram, right? And let's do that. So word frequency, of course, I will see, right, occurs. So word frequency. Let's see. It's a. Let me see. How would I want to? I'll do it. Most common. Not most common, but I want to show. Let's see. Yeah. It's a dictionary. Remember, it's a dictionary. Counter is a dictionary. I guess you could show most common. Most common. Let's say 10. Right. Let's see what happens here. Yeah. Cus. Again, notice something here. The stop words list is not exhaustive. We have a lot of not pronouns. What's the name? Cus and no. What are they? Pronouns? No. Conjunctions. What's proper part of speech? Conjunctions. Yeah. So yes. So of course, again, we could add these to our stop word list, of course, right? Again, these might be, again, this is up to you how we want to. Are these important? Another thing we could do is, of course, we have filtered very short words. Maybe these tiny words, you know, rarely will they have specific meaning, right? We want only the long words. Okay, so we have most common. So counter does all the dirty work for us. We have nice little organized list of most frequent words. So how would we display it? Again, this is one way of just simply printing. So this is how you would do it if you want to have nice little, I don't know, slightly more formatted way of printing it. So we go through most common, in this kind of most top 25 list, and notice something here, right? It's presented as a list of, well, these are tuples, think of them as fixed lists, so it's two-dimensional list basically. So we can in fact extract, for each row we extract both items at once. It's very nice, nifty in Python, how since this is giving you a pair or tuple, right, we can get them both. It's called tuple unpacking, but basically we can extract both values at the same time. And then we just print each row at one by one, basically. And yes, we see a nice little top list. Okay, of course we might want to save this too. Okay, we need to go get some coffee. We want to save this, right? So we can export them to a CSV file. I would probably use pandas, but we can use also CSV because it is much more lightweight, right? So this will show you how to do this with a CSV library. This is built into Python, right? So encoding UTF-8, of course, we open up the name of the file. We don't even need this F, by the way, right? We don't even need it here. So word frequency is just a name we came up. Write mode, encoding, UTF-8. Again, since we're dealing with non-English text, so we'll have all these long diacritic symbols. So writer, we open up a writer, we write the first row, we write header, right? And then we go and write row by row. We go row by row and write data. Of course, if you had hundreds of thousands of rows, it would be better to first write everything at once, right? But for this is we don't have that much. Let's take a look actually how much data we have.
And you could then read it in Excel, for example.
Yes, of course. Yes, yeah. But we actually, interesting enough, Excel is relatively bad at reading CSV files. You need to have some extra settings. We had some students here who had some problems reading CSVs in Excel. You need to also specify the separator. You need to do some extra work in encoding. Sometimes it works. Again, and the reason for that is not because of Excel or Python or anything, because the CSV is not really a standard. It's just whoever comes up with the idea, right? Whether it's comma or tab, or you want to use quotes or double quotes for escaping, and so on and so on. So okay, so let's take a look. We'll write, and again, how many? We can check the length first. How many do we have? So len word frequency, most common. Let's see how many words we have in general. 40,000 actually. So again, it's probably because we didn't lemmatize it, right? We skipped that step, so that's why. So probably again, so about 40,000 K because we did not lemmatize stem nor lemmatize, right? So that's the reason why we have so many. Okay, and now we're going to write it, right? Again, if you had your Google Drive connected, you could save this to your Google Drive. Let's check. Here it is. So word frequencies. Let's take a look. Right, and you can go through all there. So it's 10 entries per. You can say maybe 25 or 100, right? And you can go through. You can check it out. It's nice. Colab offers this CSV viewer, right? It's pretty, again, quick and dirty, as I like to say, but it works, right? So you can see top 1,000 list row. So you can see all the 1,000 lists, and for these 3, so 1, 1, 1. Of course, these are just single, not really meaningful. So you can see top. This is top. So this is top 100 list up to 100. Okay. So you can of course always download it, right, if you need it, and you have nice single, very simple CSV file. I imagine this will be read also by Excel or something like that. Okay. So let's go back to I'll close it, and let's go back to our visualization part, right? That's why we are here. So first we'll use word clouds. People like word clouds because they're nice little visual. So basically we'll visualize this frequency of words as basically size of these images, right? The more frequent the occurrence, the bigger the text, basically, right? I'm sure you're all familiar, at least seen it at some point, right? We've had some exhibitions here at library also using word clouds, I know, and so it's a big crowd pleaser. So what do we need for it? We need a library called WordCloud. It's a Python library. Again, if you go to PyPy, you can see it's here. You most likely have it already, right? A little WordCloud generator, right? It's been updated. It's again MIT license. Pip install WordCloud if you didn't have it. But I know that I'm almost reasonably sure that Colab has it, and I'm pretty sure that Anaconda has it too. If Anaconda doesn't have it, you would do pip install WordCloud should work just fine, right? So there's also a nice website for it, right? And you can read documentation, but as always, we'll go without documentation. So, right? So when working with a library, you need to know what kind of data it expects, right? That's the main thing what we need, right? So, and also, so it expects some sort of what kind of data it expects. For example, with Nltk, we gave it a list of words, basically. To generate this text object, we needed a list of strings, right? That's what we had to do before in our pre-processing. You know, we had a tokenize perhaps, right, and then we got our list of words. So here, well, we'll need two things actually. First of all, we'll need a mask. We'll need a mask, right? So I'll show you what the mask looks like. So we're gonna have a little cloud, right? We like clouds. So here's this at Amazon cloud. They're storing an image. We're gonna download it. It's using actually called URL lib request. This is built in. This is built-in library used by requests. There might be a way of doing it also by requests, but I know this works better, right? So it's actually, so URL request, you retrieve the URL and you save it actually. That should work. Let's take a look. And yes, and let's take a look if it's here. Here's my sample cloud. There it is. Let's check it out. And basically, yeah. Okay. So this is, if you want your own custom clouds, you need to have something which is like this, meaning you can use Photoshop or whatever, well, anything which saves PNG images, you know, even Paint, and you need the black area is where the data will live, and the white will be where the data will not live, right? So you can come up with some pretty nice designs, you know, using fill, and again, it's up to designer side for you. Okay, so that's what we have, right? It's like it's basically a mask. It's like a mask for the image, and of course you could have big black. That this will count as basically, it'll be a nice little, just a block of. It won't be a cloud then. Okay, so we have the image here locally. That's good. That's going to be our mask, right? And now we need the word cloud, and we can specify the size, the background color, the color map, the colors of the words. You can read that. And it's actually using, underneath, it's using some library called Matplotlib. This is a library which has been around for over 20 years. It has a lot of options. It's actually used often by other libraries as, you know, for visualization. It gives you nice, quick results. So let's take a look what else do we need here. So mask, right? Again, it masks, right, the lines. It has like extra coloring here. And then we have some settings, you know, width, height. Color map, this is again what kind of colors we're going to use for the words. Maximum words 150, right? And minimum font size 4, right? Don't show any very tiny. And maybe add a contour. Cloud mask is a mask which we just generated. And now we have a word frequency, right? So it actually takes a counter as default. So it takes a word frequency as is. So WordCloud. So WordCloud is smart enough to take a counter object as is. We don't have to. So we could of course maximum words 150, but we had 40,000, right? So it's only going to take top 150 words to use the counter object, right? So again, let's double check before we go. Again, so type word frequency. So that's basically, so WordCloud wants this. It's a collections counter object, right? So that's what it needs. So that's what we're gonna, this is what we will pass to our WordCloud generator. Okay, so let's take a look. Everything is good. Only thing is question is, will it save? There are some people experiencing problems with saving. This is the line. We might not be able to save it. Let's take a look now. WordCloud, we generate a WordCloud object, and then we are gonna check figure size, and we're gonna show this image. Okay, let's see. Let's run it. Okay, it didn't work. Okay, I did not import something. Okay, it didn't import in NumPy. Right. We didn't. I forgot to. Oh yeah, I didn't know this. I didn't import anything. Right. I need to import WordCloud. I need to import NumPy. I need to import Matplotlib. I need to import also image libraries. So I need to import all of this, and now it should hopefully work. Let's take a look. Yes, it works. Okay. Right, so a little cloud thing, right? We can see, of course, the big word is "cus." Of course, this is because we used it for all the small words also, right? Latvias, right? Viņš, she, he, right? And so on. Not maybe, again, valsts, country, right? So maybe we will want to do, maybe only do the long words. So how would we do this, right? So how would we make a word cloud? Since we have time, I think we have time till 4:30, right? About 4, yeah, around 4:30, right? We could do this. Let's do another cloud, but I want the counter out of only from the I want to filter out all the small words, right? That's a possibility, right? We could, of course, go back and clean up the short words from our original, right? That's also possible, right? Where's our counter? Words clean, right? We can start here, right? Right? We could do this here, right? So let's do that, right? Give me something. So did everybody get a nice cloud? I hope you guys get a cloud. No, some got, some didn't. Right? Maybe artists can see those where you got stuck, right? I would like to something. I don't want these again these extra small words. So my idea is this: I will filter out or. Oops, oh no, again, I can always escape B. It's okay here. So, right, this is what we used, right? But I want the words clean, short words, long words, right? Equals basically word for word in words clean. So what will I do? If length word equals more than, let's say, 3. Yeah, so four letters. So we want to only see long words, right? Right? Mm-hmm. Okay, let's take a look how many we have. Then long words. So how easy it is to. So we got rid of about 139, and how much did we have before? Let's see. Let's take a look. 151. Okay, so we got rid of quite a few. So all these small words, right? None of them have any real meaning, right? Will be gone. Okay. So what do we do now? Next, we get a frequency, right? So we need a frequency. Right. Escape B. So long word frequency is basically a counter, and that's it. The rest of the code is ready for you, right? The rest of the code we already made, so we just have to copy the cell and we can run it again, right? Of course, it's also, by now we might want to make a function out of this. Would be nice, right? It'd be nice to do it, since if you do it, if you keep doing things 2 or 3 times, it might be nice to have a function for all of this work. So let's see long word frequency. Let's look at the top 10. Right, most frequent, right? Most frequent 10, right? No, most common, sorry, most frequent, most common, right? Right? Yes, okay, so this is much, well, again, Minja, she, he, again, this would be in a stop list, but maybe this is important, right? So, okay, so that's slightly more meaningful. So now we can do one more word cloud. Let's do one more word cloud. What I'll do is I'll just copy the cell. Yes. Yeah.
Just the last line.
Okay.
Where the frequencies are.
Okay. Yeah. So this is exactly the same we did before, except we just rename it. So let's wait for everybody to see this. Okay. Now, basically, I will copy the whole cell. Everything here, right? For now, right? Control C, and I will make a new here, right? I'll copy it in. So what do I need to change? I need to change this one, right? I need to change at least this long word frequency, right? Long word frequency. So I only need to change one line, long word frequency, different. It's still a counter, right? And what else do I want to change? Well, since I want to say another, I'll still use this. Again, I'm still using this cloud, okay? I only have one mask. Maybe I want different mask. You can sometimes people use pictures of people and things like that, outlines. You can get really fancy. And I'll make this my WordCloud, WordCloud long words. Okay, words over words, WordCloud 4 or longer. I don't know, not a very good name, but it tells you what exactly length 4 or longer. Okay, something like this. Okay, and let's run it. Maybe slightly more interesting. Okay, yes, so country, right? So this is slightly more meaningful, right? Again, Janis, John, Rigas, Jelgava, right? And sometimes you can, of course, people, it's like that psychology test, what's a Rorschach test, right? Sometimes people think that there is some meaning within these connections. There really isn't, but you can have a lot of fun with that, actually, right? Are they somehow connected, right? So, right? They're not real. No, they're real. It's just the algorithm for WordCloud. It just tries to fit the words, basically. They don't have any connection as far as distance or anything like that, basically. Right. Okay. So we have it saved here, right? We have it here as well, right? So you can download, right? Here it is. You can download it here. There's the other one. Yeah. So okay. So again, it depends. Again, very much depends on what you feed it in, right? As long as you feed some sort of counter object, there might be something else you can feed in, but counter works very well. Counter objects, again, and you provide a mask where to put the words, and you have nice results. So this will be one of your assignments, will be to generate a cloud of your own for your own corpus. Right, so make a counter and generate this. Okay, so let's move on to our second part of this this session. Let's look at the other library, other major visualization library. How are we doing, actually? Are we
time-wise? We have half an hour.
Yes, let's do roughly half an hour. And let's take a look at Plotly. So what's Plotly? Plotly is a major library for interactive graphics in Python. So it means you actually get a live movable graphs, right? So we'll take a look at some of the simplest graphs we can do with Plotly. So this home page is here. We can click here, actually, control click. But there's nice. It has one of the, when you're working with libraries in Python, you should always check what kind of documentation it has, right? Nltk has pretty good documentation. Plotly has fantastic documentation, has a nice reference. It's one of the strengths, right? If sometimes projects which are, well, important, but they don't have very good documentation, well, if you have a choice, take the one with good documentation. Because again, if you need to look up things, then it will be with nice examples, right? He has Plotly, and of course supports. It's also available in R, in Julia, other languages, right? So it's if you work in one language, it also translates nicely to another language. So you can see how many different chart types it supports. We will be using it for bubble charts, which are basically a modified scatter plots, basically, right? So scatter plots, we have x, y, so that's what we're going to do. And what kind of data do we have? We have basically our most, we'll be using our counter or most frequent words. So x will be the words, the tokens, the words actually, right? And y or y will be how many words are there, right? So we'll be we import the sub library from some module from Plotly, and let's see. So it should be available on every machine. It's so Plotly. It like 2 years ago it was not included in Colab, but now it's included. I know Anaconda also includes Plotly, so it should be quite nicely available. Let's double check what kind of Plotly. So import Plotly. Let's check what kind of version we have here. Usually most libraries have something like this. I'll check. I don't know if it exists. Yeah, it exists. 5.5. That's pretty recent, actually, right? What's the most recent version? Oh, to me? Not. You had to install it? Yeah, you had to do an environment and install it, right? And apply, and then it installs. What version does it install? Check it, yeah, import Plotly and check the version. You can also, of course, check it in, remember, you can also check, well, of course, my Anaconda, right, has it, right, because, of course, I have installed it, right? If I check Plotly here, right, I have 5.6 here, actually, right, slightly newer version. Again, Google Colab is not going to be the latest and greatest. It will always lag a little bit, right? We're still using Python 3.7, I believe, on Colab, right? So slightly older libraries in Colab, right? But again, but if it works, right? So I think the latest version is where's our Anaconda, right? I'll put here. They usually tell you what the latest version is. 5.9 is actually the latest one, right? So there's maybe a few graphs not present. But again, we'll be using some basic. I mean, there's already so many graphs present that we won't be able to go through all of them. We'll only just look at the basic scatter plots. Okay, so 5.5. So what do we need? Again, as working with libraries, we need to figure out what kind of data and what kind of format this library wants. So for a scatter plot, you need two lists. You need X values and Y values. Yeah. So notice, of course, case sensitive. We could have used anything. We could have used any name, but X symbolizes array list of X values, right? Basically, right. So it's often used like big large X and large Y, based sometimes mostly large Y, right? It symbolizes basically a vector of values. So we have this is basically to keep track how many we want top 100. Let's look at, so we're going to use top 100. We can change this later, of course, and then we'll basically, what's going to happen with this recipe? We have blank two lists, right? Two lists. We start with two lists. We start with two blank lists, right? And we go through most common, right? We go through top 100 most common, and one by one we add them to X and Y. There are other methods, but I think this is knowing what we learned yesterday. Append. This is simple enough, right? And let's check, right? So we can check this most common. Kas nav to Latvijas tas, right? So we see again when working with data, of course, you have to be careful if your values, your X, Y values don't separate, right? Because somehow, but here I think it's pretty clear. We're going pair by pair, so we're adding one by one. Well, it looks like we didn't make a mistake, right? You can check, of course, we could double check, right? That word frequency, most common, right? Let's say 5, right? Let's double check. Yeah, so you can see cast is 10,084 now. So it looks like it worked correctly, right? Again, so we have our data X and Y, and let's see, it's really simple. Go figure. So we create a figure and we pass data, right? So go scatter plot, and we give X is X, Y is Y, and we do a marker mode. We could use, there are other modes. There are other modes such as line mode or combine line plus marker mode, right? So let's take a look what happens here. You can only see it here, but let's take a look. Yeah, it worked. So let's take a look. So we got nice little dots, and this is a standard distribution. You can see it looks pretty good, right? What's the law? Not Zipf's law, but what's the law for distribution of letters, of words, of tokens, right? Which is shows how this sort of log scale, right? Or this reverse log scale, right? And that it looks good. You don't see any strange outliers, right? Of course, we had a very small data set. We only had 5,000 documents, and we had what, 300,000 something. No, how many tokens? We had 100,000 something tokens, right? So it's not very big data set, right? So, and again, so notice a few things about this Plotly. first of all, it is interactive. If I want to zoom in, I can, right? I can zoom in as quickly as I want. I can check, I can hover over each item, and if I want to, I can take a screenshot here, download plot as PNG, right? I can pan, I can zoom, I can go around like this, right? I can do here, right? And if I'm tired of zooming around, I can go home. Here's the home icon, reset axis, right? So it's pretty nice. So again, I can download plot as PNG. So this is actually interactive, basically interactive graph. However, as nice as it is, we want to be, well, we want to be bubblier, right? We want to change the size and we add the color to our graph. Okay, let's do that. So, at the simplest, right, the syntax, we go figure, data, scatter. So we need to add a few more options. Let's add size. So, well, so we need basically, again, we need some, so what does it, we have a two-dimensional plot, basically, you know, we have a XY, it's a two-dimensional plot. We can add more dimensions. So we can use size and color. If we want to represent some more data about our data. I mean, some more attributes about our data. So let's use sizes, could be a length of the word. Again, I don't have any extra metadata for these tokens right now. So I'll just use length because it's quick and I can quickly generate them. So what I do is I go through all the words, right, in X and generate the corresponding list of their length. It's their lengths, right? So I say I don't have any filter here. I don't need a filter because I want exactly the same size. And I say, okay, for every word I want its length. So 33283, right? Because why is 3? Let's check. Look, 3 is cus right now is 3. So for each word we generate the length. Okay, so we have a nice little list of number. So we can utilize it. So marker size. I could have also used the constant size here instead of a list of sizes, right? So basically I'm saying I'm providing a custom list of sizes as a list. Again, so Plotly wants lists. So if you know lists, you can work with Plotly. So it wants a list of X, wants a list of Y, wants a list of marker size if you want to modify it. So let's take a look. Okay, and why didn't it work? Size is not different. Yeah, I didn't run this code. Yeah, I didn't run it. I showed it, but I didn't run it. Yeah. So it said not defined. So it means I need to generate it. Okay. Well, it worked to some extent. I have some really tiny, right? So the size, of course, you could read the documentation, what the size, how to determine, but basically I'm going to make it, I just said number times 4, I want it bigger, right? So times 4, so I'll make big sizes, right? So I have my length, right? I just proportionally multiply everything by 4, right? So I have big sizes, right? Let's take a look. So every little bubble should be 4 times as big. And indeed, again, so that's up to you how big you want to make it. So that looks, I think, slightly nicer. You can see, right? So these are the longer words. You can see they are proportionally bigger, right? Again, it's up, of course, you could have used something else. If some other attribute was more important to you, you could have used this to show this attribute, right? So we have lengths. I'll go home. Right. So we have sizes. Now let's add some color to our graph. Again, default color is this bluish shade. We could add color actually, right? And actually, let me first add a single color. Let's see if we can do that. So I'll copy this existing code. I don't need the big size anymore. I already made them, right? So I already have them in memory. So let's see if this works. So marker color, right? I could have, so I have a new option, right? Right. Let's see if this works out of box. So standard. I'm pretty sure I'm doing this by memory, but I'm pretty sure this works. Yeah, it read. Yeah, so it works. So single color works. So single color. right? If you look up documentation, you can find that all the basic colors. I can do violet, works, single color works, right? So what I'll do, right? I'll change it to maybe violet, right? Marker color, let's try violet or something like that. It's just a string. Again, notice something here, important. So when we're passing the syntax, again, whatever is open has to be closed, right? So comma, comma, comma. These are all options to this plotting object. I mean, these are parameters to this scatter. So we have x, y. These are pretty much required. Rest of these are not strictly required, but we are using them to customize this. Let's see if violet works. Yeah, it works. Yeah, maybe not my favorite, but okay, it works. Right. So there are many colors. Of course, those who remember our color theory, we can specify it actually extremely specifically, right? So we can do actually in this syntax. So we can do red, green, blue. Again, these are takes 256 values from 0 to 255, right? And we can specify them using this syntax. Again, those who have done web development know this is standard web development setting, right? So because of course we are making a web page basically. So however, like in this example, I need 100 colors, right? I need so I either pass a single color or I need to pass 100 colors. So this would be a way of passing. So notice this multiplied by 25. I have 4 colors and I multiplied by 25. So I made a huge list. So I made a, so by multiply by 5, I made a list of 100 out of my initial list of 4 values, right?
So you repeat the initial
yes,
list?
You repeat, yeah, repeat. So this is one, we didn't cover this yesterday. So with lists, you can multiply lists by themselves and you will have a copy, right? Make a bigger one, right? If you need to, it's like a padding basically, right? So you need how long you want, right? So for example, if you want, for example, let's say, I don't know, Valdis on beer, right? Right, times 10, right, or times 5, right? Oh, and there's a comma here, there's a right here, right? So, yeah, looks good, right? Yeah, Valdis beer. Okay, so that works, right? So that's what I'm doing here, right? So, so we have my colors. I'm double checking. Yeah, you can see how they repeat. So they're repeating colors, and we can see what happened here. We're still using big sizes, and colors now are 100, right? So let's take a look. Yeah, so now of course again, so these colors are not really meaningful, they're just repeating 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and so on. Okay, but we maybe want to have a shade or custom shade depending on your, again, using the length as a word length as a determining factor. Again, you could use anything else. So let's come up with a formula. So here's an idea how to create custom colors. Right. It's a simple, very simple function. Right. I create a function called getCustomColor. In comes word, and now our task is to determine what kind of color it is. So what I'm doing is I'm using a f-string. I type up a template of what I need, and I'm keeping these green and blue stays constant, and I'm taking the red maximum value. Depending on the length of word, I'm taking 15 units off. So theoretically, if I go down to really long word, it will be really lacking red. So I start with the full red and I go down. Again, it's a really simple calculation, right? And you can adjust it basically. So you can see this example, how this example shows how you can do calculations inside right template. So you can do not only variables, but you can do also calculations. So 255, that's a maximum, minus the length of the word times 15, right? If the length of the word is nothing, it will be 255. So let's take a look what happens. So we can test this function. So get custom color for Valdis.
Shouldn't you run, like, what if it goes negative?
Yes, if you had a really long word, it will go negative.
Yeah.
right. So far, let's think. So that'd be 15, right? If you had a word of 15, but looks like there's no words pašvaldības. That's how much. That's 14. We'll see. It happens, right? Yeah, you could have used the round or max min. That'd be even perfect. If you want to be exactly right, it'd be what min, right? Min 0. This would be exactly. This would be completely correct, right? So 0. So minimum value 0.
Oh no, maximum value, no?
Minimum. No, for max. Sorry, you're right. Maximum. Yeah, maximum value. Yeah, correct. So maximum. This is built in. This is Python. So, but of course, this is. I don't want to complicate things. But yeah, good point. So maximum value either 0, right? So that's you can't go below 0, right? So can't go below 0 or whatever is over here, right? So in case you encounter some really long word, because 15 times 16, 8, 17, yeah, 16, 17 letters, if you have something like that, it will go down to 0. Okay, of course, this is just really quick and dirty calculation. So let's take a look at Valdis, right? Let's Valdis or Uldis, right? Uldis. Okay, and run it. Control Enter. Yeah, so you get the RGB. It looks okay. Yeah, it's exactly what we want. So, but only our task is we need to go through all the words, right? So, again, our friend list comprehensions to rescue, and we are going to, for each word in our X, right? We have a huge list of words. We are going to generate a list of custom colors. So for each word, in X, we are going to generate a custom color, right? Some color, depending on what get custom color returns, right? So we have a loop, basically going through, and we generate new lists. So let's take a look. So, of course, these are same because remember these are short words. They had same 3 letters or something like that. And this is different. You can see it works, right? It's working. Okay, we have our custom colors, and I think we are ready to go. Right, so let's do it. So, X is X, Y is Y, mode markers, big sizes, marker color, custom colors. Okay, let's do it. And now, I think it looks pretty nice now, right? We have this shade, and we have our Latvia. And also notice how we can, if we go over, we can see the values, right? The counter. You can also, if you read the Plotly documentation, you can also adjust the hover messages. There's quite a bit of customization available in Plotly, right? Pretty nice. Well, that's my subjective opinion, right? Again, double click to zoom out. Actually, double click. Oh yes, so double click also works. So there's lots of nice features come in for free with Plotly, which you don't get with, say, Matplotlib, right? So again, this is a library we use quite a bit here at the library, right? In my research. So this will be one of your tasks, right? To generate. Yes.
This fourth bubble, the fourth big bubble is Latvia's, but the word management is not here. What does it mean?
Oh. Because okay, yeah, let's zoom in. Good catch. So pan, we want to go in, right? The thing is here, right? It's here. Basically, in a default setting, these X values, since it doesn't Plotly doesn't have enough space to put all the 100. I think we had 100 or 150 words, right? 100. Yeah, it does not have space for all of them in our limited drive. So in a full-blown image, it doesn't have so it skips some words here. Basically, it's here. So if you zoom in, it is there. But of course, what do you do? There's an option. You could do some. You can also make the x-axis 45-degree turn. You can try to squeeze in more. You can lower the font. There are many options in Plotly. You can lower the font size, or you could of course show less data as it is, right? That's another option. You can show the only top 50 words, right? So yeah.
And you can zoom in like you.
Again, yeah. Again, as soon as you zoom in, right? It'll see as soon as Plotly sees. Okay, I have enough space to show all the letters, right? It will show it, right? So, okay. So yeah, of course, this is completely again up to you how much customization you do. as with Plotly, of course, it's the hard part is knowing when to stop. When do you want to stop and fiddling with this data and making these adjustments, right? You can do this for a long time. So you can add, of course, you can add title, right? You can add things like, let's add title. We'll say maybe top words in Latvian. What's the name of the corpus? What's the name of the corpus? Yeah, I think I have it here. Okay, let's check our variables. Do I have it? I have it. What is the name of it? Oh, it's download URL actually. Yeah. No. What's the name of it? We had a URL, I believe, right? Yes. No. It should be somewhere here. Or of course I could go up. I will show you how you could do it. You could of course make it. Yes. So you could go here, right? URL, but I see. Yes, stop words. No.
LV old newspaper.
Yes. Yes. Of course. Right. So. Right. So where did I? Oh, I think I changed URL twice. Yeah. Okay. Here it is. Right. Yeah. That's it. So yeah. Of course, I could do this. Of course. I was going to show you if you use the URL. If you had said as a variable, you could use the title somewhere here, right? So I want to show top words in, right? You could use this f strings here, right? So file name, right? You could of course do this here, right? File name. If you had this, right? I want to show you this part here, right? Right, and you could do this f right here, assuming this came from, again, using the interpolation, right? Something, so you have if you change this and you run it, of course it will run again. So title I think will work. Of course you need to add a comma here. Okay, I think it's correct. Let's run it. No, I didn't do it. Let's take a look. I believe it's take a look. Title.
So many options.
Oh, there's a lot of options. Again, you can do completely full. Let's take a look at the documentation. It's quite nice. Basic charts, scatter plots. On title. Title is good, right? So what did I do wrong? Let's take a look at the error. Yeah. Okay. Let's take a look. Mode. Text. It's not here. Let me see here. Label. Yeah, that's bad property basically. But I know you can add it separately. But I think I maybe. Let me see here. Go scatter. Maybe it isn't here. Oh, maybe I think it wasn't here. Yeah. Okay. Yeah. I am pretty sure it wasn't here. Maybe. Yeah. It was. Maybe it was in top level. I think. All right. Let's try this. Figure data. Let's say. I think it wasn't here. Let's try this. Nope. Also not here. I know you can do this. Okay. Let's go back. It works, of course it works, but there's a way. So add title, Plotly, add title. You can do update, right? Setting the. You can read, of course, documentation as well. Done. Yeah, we can do this. I want to do it. You can do it later, of course, right? Oh, here, title. Title, labels. Go. Graph objects. Name. Name, I guess it's called name. Yes, it is name. Or we can do title, update layout. Okay, that's what I use usually, update layout, right? We can do this afterwards. So here, I would do it here. Basic title. Before I show anything, I update the layout. You can do a lot of optimization. So word frequency. For frequency, for file name, right? And you can do x-axis will be access title will be words, right? Tokens, words, right? And this is the frequency, of course, right? You can say what the kind of frequency it is. And the rest, we can change font. This is an example how you can change font, right? You can change. This is an example how to example on how to add title, x-axis, y-axis, and custom font, right? And sizes, right? So we can see this, right? Monospace, right? You can see size, color of the font you can change, right? Let's take a look. Yeah, okay, it's using kind of funky. So what's happening, it's not finding Courier, I think it's using monospace, I believe. Oh no, Courier New, it's using Courier New, right? So, pretty, again, right, getting silly, but yeah, you can do quite a bit of customization here, right? So, you can also change size of this plot and how big you want, and so on and so on. You can have multiple plots, so it's quite a powerful library. So, your task actually will be to create a word cloud. I can give you a head, but you can also try playing around with Plotly and make your own plots. So I recommend starting with the basic. We went pretty far, right? Start with the basic scatter plot, maybe this one here, right? You only need X and Y, right? You can start here, and then you can build up as your knowledge grows, you can build up. So thank you. We're going to take a 10-minute break right now. Thought since it's not realistic to keep going for 3 hours. So, right, and we'll continue then. I'll add this record.